You know the Avogadro? Yeah, Avogadro is the scientist. There I am. So here we are. That is Avogadro constant as well. He worked for so many gases and elements and compounds as well. So right now, would you like to share about the Avogadro? Let's go there. Here we are. In chemical calculations, we have stoichiometry. And stoichiometry is the relationship between the numbers of the moles of the reactants and the number of the moles of the products. And if you are having 2 or 3 things, look at me here. If we are having 2 things, alright, that is pair. If you are having 12 things, that is, yes, 1 dozen. But if you are having 6 into 10 to the raised power 23 things or the particles, that is equal to 1 mole, right? So 6 into 10 to the raised power 23 is a big number, 6 and there are 23 0. So 6 0 0 0 0 0, it's a big number. So that is equal to 1 mole. And then if you are having an element and this one is the atoms, this much atoms will have 1 mole, and that is equal to the mass of that element. That is called relative atomic mass of the atoms. And if for the compounds, if you are having this much number, Avogadro number, and that is equal to 1 mole, we have here 1 mole, and that is equal to relative atomic mass of the compound. And for the gases, if the molecules are 6 into 10 to the power 3 molecules at room temperature and pressure, then that volume is 24 decimeter cube, and this much particles or the molecules having 1 mole. These are the 3 equations, right? So we can calculate them with ratio method or unit method. Let's go for the ratio method. I will tell you. Here we are. 6 into 10 to the raised power 23 atoms, that is equal to 1 mole. I told you already. So when Avogadro, when I put these much atoms on the weighing machine, then the mass will come, and that will equal to relative atomic mass. For example, if we are having carbon is having 6 atomic number or the proton number, and 12 is atomic relative mass. This one is mass. Why? Because in 12 is the sum up of neutrons and plus protons. That is atomic mass. So here, if this much atoms of the carbon Avogadro put on the weighing machine, and the mass will come here 12 grams. So automatically will come there. Same way, if this much particles, in this one case, you will take the molecules, and then molecules is equal to 1 mole again, right? And now the mass will be relative molecular mass. Now, for example, H2O, here we are, H2O, that is the molecule, that is the compound. So molecular mass, if this much molecules you will put on the weighing machine, and the mass, if Avogadro number of the molecules will be taken on the weighing machine, and then it will be equal to molecular mass. For example, water is a molecule. Let's calculate the mass, molecular mass. 2 atoms of the hydrogen, and then 1 of the oxygen, because 1 is here. 1 of the oxygen is there. Let's have atomic mass of the hydrogen is 1, plus atomic mass of the oxygen is 16. 2 multiplied by 1, 2, and this one is 6. You are having 18 grams. So if this one molecules of the water you will put on the weighing machine, it will come 18 grams. I will show you the molecule of the water. Here I am. 1 oxygen is there. 2 hydrogens are there, alright, and they are having with the linkage, and that linkage is the covalent bond. Here, hydroxygen will make 2 bonds because 2 holes are there. 1 and another one. Here we are, hydrogen. Here, another hydrogen. Here. So that is 1 molecule. 1 molecule of water. But how many molecules? If you will take 6 into 10 to the raised power 2, 3 molecules, and you will put on the weighing machine, automatically will come that is molecular mass 18 grams, and that will be equal to 1 mole. Now these are two equations. One of the equation is this one, another equation of this one. So that equation, one equation, another equation is this much equation. So there are two equations. So one of the value in your calculations will be known value, another value will be unknown value, right? So in the ratio method, unknown value you will write in the right hand, right? And the known value you will have in the left hand. For example, you will see if 18 grams of water will have 6 into 10 to the raised power 23 molecules, right? For example, 7 grams of the water, how many molecules? How you will write it? You will write this one value here divided by this one value 18 grams and multiplied by 7, and molecules are there. So easily you can calculate in given mass how much molecules are there. Same way, let's try to calculate this one and this one value. For example, you will have 1 mole. You can also connect with this one mass and this one mole. So in 1 mole, here you will have 18 grams, right? That 18 grams is actually molecular mass, right? And this one is 1 mole, and mole is represented by somehow with the letter small n, right? So in 1 mole molecular mass, 1 mole 18 grams. You can also write like that, 18 grams is equal to 1 mole. And for example, in 2 grams, how much mole? Line up there. This one, 1 mole divided by 18 grams multiplied by 2. And you can easily calculate in given mass 2 grams how much moles are there. You can write like that. Alright, with the help of this one, you can, in given mass, you can easily calculate the number of moles. So we can have here, up is the moles and the lower is the molecular mass. So the shortcut is number of moles can be calculated with the help of given mass or molecular mass if there is compound. Another shortcut, if you are having the element, the given mass is there, that mass is given to you, and relative atomic mass is here. Another, moles. Avogadro number 6 into 10 to the raised power 23, and the given particles. If any particles are given to you, you will write here the particles and divided by the 6 into 10 to the Avogadro number. You will get the number. Alright, with the help of these equations, we have calculated the short method to calculate the number of moles. Let's see the next one. Here we are. Here, elements are given to you, and for example, the carbon, 6 is the proton number and 12 is relative atomic mass. So atomic mass is the big number that is given in the periodic table. Here, the next one. For example, 7 proton number and the mass number, relative atomic mass 14. 8 is proton number and 15.999 means 16 is the relative atomic mass. So atomic mass is the big number, right? You can easily calculate the proton number by subtracting 16 from 32. You will have the proton number. So this number is called nuclear number as well. Alright, here, the next one. Here is one problem that is given in the books. For example, in this one reaction, there are 2 molecules. This number is given the molecules. 2 molecules of hydrogen. So here we are, 2 molecules of hydrogen. Let me show you. 2 molecules of hydrogen. In one molecule, we are having 2 atoms. Here we are. So the 2 atoms are there. Here. So that is 2 hydrogen atoms, right? 1 molecule. So 1 molecule. These are 2 molecules of hydrogen gas and 1 molecule of oxygen. Alright, let me make one molecule of the oxygen. And oxygen and another oxygen, I told you already, both of them, they will have double bond because there are two holes here, double bond. So another oxygen. So we will have here, double bond. So this one is one molecule. So here is one. It is not written or understood that is one molecule. Two molecules of hydrogen gas, one molecule of water, and there is one molecule of oxygen, and two molecules of water. So now, in terms of this equation will give us, in terms of the moles, you can say 2 moles of hydrogen gas, 1 mole of oxygen, 2 moles of water. In terms of mass, you need to calculate the relative atomic mass here. Relative atomic mass of the hydrogen, relative atomic mass of the oxygen, and relative atomic mass of the water. In terms of the volume, 2 volumes of hydrogen gas, 1 volume of oxygen gas, this number, 2 volume of the water, right? Let's move the next one slide. Here we are. This one example number 1. So calculate the mass of the solid obtained when 16.8 grams of sodium hydrogen carbonate is heated at strongly until there is no further change. The equation of the reaction is this one. So sodium hydrogen carbonate is given in the equation, that is mass 16.8, and you need to calculate the mass of sodium bicarbonate, right? So here is the data, we are collecting the data, right? Now here with the help of the mass, I told you the shortcut, number of moles equal to the mass or molecular mass. So mass is 16 gram, molecular mass of this one, calculate, that is how much? That is 84. So 16.8 divided by 84, you will get 0.2 moles. With the help of the mass, we will calculate the moles of this one. And with the help of the moles of this one, we will try to calculate the moles of this one, but sodium carbonate. But that can be done with the help of the equation. Here we are. 2 moles of sodium bicarbonate give us 1 mole of sodium carbonate. So, but we are not having 2 moles. We are having 0.2 moles. We have calculated already. So 0.2 moles will give you again the ratio method. 1 divided by this one 2 multiplied by 0.2, you will get 0.1 mole. So 1 mole is calculated, right? Now with the help of the moles, we can easily calculate the mass. Again the same formula here. Moles given mass over molecular mass. Moles we have calculated 0.1 is equal to mass and molecular mass of this sodium carbonate is 0.6 grams, right? Mass will left here and this one will go there. On the other side of the equation, it will dividing, there is multiplying. So mass will 10.6 grams, right? And that sodium bicarbonate is the, you know what? That is your in your ordinary language we call it the baking soda, right? The baking soda will give you carbon dioxide, evolve, water vapors will go away, and only this one solid will obtain in the dough. That will make the dough rise. Okay, here we are, the next one. So value, our value is respect, right? Respect is like a paycheck, right? It has to be earned. Whatever you will give to the others, it will bounce back to you. Alright, so the point is give respect and gain respect. Right? Respect yourself. Others will respect you. Right? And again, respect others and people will respect you. So by 2 methods, you will gain the respect. Respect yourself. You will get respect. Respect others and they will also give you respect. Alright? See you.